Hello everyone, my name is Arohi. So guys, in my today's video, I'll talk about object detection. So object detection is a technique in computer vision that focuses on identifying and locating objects in an image. So object detection algorithms generally provide the output in the form of bounding boxes and class labels. So what are bounding boxes? So bounding boxes are just like a rectangular boxes drawn around the detected object in an image or a video frame. Okay, and with that bounding box, the algorithm will also assign a class label to identify what object has been detected. Okay, and the algorithm will also provide you the confidence score for each detection. So this is how object detection algorithms work. So there are various deep learning object detection algorithms are already there in the market. In my today's class, we will use one pre-trained object detection model. We will understand the code properly, how to use that pre-trained model. Okay, and we will then we will try that object detection model, okay, on an unseen image, and we'll see how the model perform the detection on it. Okay, so guys, in my next video I'll show you how to work on a custom object detection model. But before moving to that part, it is important to understand how object detection model works in general. So today we are going to cover that. Okay, so let's start. So guys, for that, this is my GitHub repo, and under this lecture 6 you are going to get the code which I'm going to discuss today. Okay, so this is the code. Okay, this is the Jupyter notebook which I'm going to show you today, and this is the image on which we are testing. All right, so now let's go to the code. This is my Jupyter notebook, and guys, remember I have already told you that I have shown you how to create a separate environment, and every time whenever you want to try any code, you need to activate that environment and then you can work on it. Okay, so how you can activate the environment? Just open command prompt, enter in the drive where your environment is. So inside D drive I have this folder, and here I have created my environment, and now I am activating it. Okay, now I'm opening the Jupyter notebook, and you will see your Jupyter notebook here now. Yeah, here. So under this video 6 I have today's code, and this is the Jupyter notebook I'm talking about. Let's open this Jupyter notebook. Now let me increase the size first, zoom it. Okay, so first we will load the pre-trained model, and in my today's class, which pre-trained model I'm using? Faster-RCNN. Okay, so we will load the Faster-RCNN model, and you can see here, this is how you load it. From torchvision.models.detection, from this location, from this module, we are loading Faster-RCNN Resonate 50 FPN. This model we are loading, and this is a pre-trained model. This model is trained on COCO dataset. So guys, COCO dataset have 80 classes, 80 different classes, and if you want to know more about COCO dataset, just write COCO dataset. Okay, let me write again. Just write COCO dataset and then enter. So this is the official link website of this COCO dataset. Open it, and here you can know more about this dataset, and dataset under this go to explore, and these are the 80 different classes of COCO dataset, and the model which I'm showing you today, this model is trained on these 80 different classes. Okay, so Faster-RCNN is an object detection model. Resonate 50 is a backbone, and Resonate 50 is basically a convolutional neural network, and which have 50 layers. Okay, and we are using it for feature extraction, and then we are using FPN. So why we are using FPN? To refine the feature extraction process. So guys, if you want to know more about this Resonate 50 or what is FPN, how they work, what are their architecture, so on my YouTube channel I have separate videos on these two topics. You can search and you can learn more about them. Okay, so this is the model we are loading, and here we are initializing the model, and we are passing these two parameters, pre-trained true. Pre-trained true means we want to use the pre-trained model. Progress false. Progress false means when you'll execute this cell, let me execute it. When you'll execute this cell, so there is a downloading process will go on, which will download the pre-trained model, this Faster-RCNN pre-trained model. Okay, so this progress false means you don't want to see that progress bar on the screen. Okay, so if you will if you want to see that progress, progress bar, that how much download has been completed, then you can make it true. Okay, so after that, once you initialize the model, after that we are calling it like this, .eval. Why we need it? Guys, this is a mandatory step if you want to use a pre-trained model. So you need to, before making predictions, you need to write this .eval, and then you can try testing your model. Okay, so this is how you load your pre-trained model. Now once we load the pre-trained model, now we want to make the predictions. Now how we can make predictions? We need to select some image on which we want to perform the testing. So for my today's class, this is the image on which I want to perform testing, this image. Okay, and over here I'm just displaying the image. And how I'm displaying the image? I'm just using the Python imaging library, and from that I'm importing image and I'm just displaying that image. Okay, so this is our image on which we want to perform the testing. After that, guys, in my first or second video of this lecture, I have told you that Pytorch, whenever you want to work in Pytorch, you need to convert your input data into a tensor. Whether it is a text or an image or a video, you need to convert your input data into a tensor. Then only Pytorch model will accept your data. Okay, so now we need to convert this image into a tensor. And how we do that? We are using this transforms from this module, from torch vision module. We are using this submodule, transform module. This is the image. Here we are just defining the transformation. Defining the transformation means what all transformations we want to apply on the input image. So here we are just applying one transformation. What is that? That we want to convert our input image into a tensor. So sometime you want to resize your image, that also you can provide it over here. Okay, so this two tensor will convert the image into a tensor. So here in this line we are just defining the transformation. Now we want to apply that transformation on our test image. So what is there in our test image? This image. So, and here in this variable we have defined the transformation. Now we want to apply all the transformations on this image, and after that you can see we get this kind of output. Okay, now this is our tensor. So earlier our input was like this, but after converting it into a tensor, our input data, our input image looks like this. This is a 3D tensor. So 3D means three-dimensional, where 3 stands for a number of channels. This is a colored image, RGB, 3 channels. And here you can see this first matrix is of for a red channel. This second matrix is of green channel, and this third matrix tells you about the blue channel, RGB. And you can see all the values are normalized between 0 to 1, right? So this is a 3D tensor. So now this will become the input to our model. Okay, so okay, before moving to that part, guys, right now what I'm doing here, we have converted the image into a tensor. Then we are just checking the shape of it. So you can see that we have 3 channels, height and width of the image. So guys, this Pytorch accepts the data in this format: first channel C, and then the height and the width of the image. Okay, now we need to perform one more step before giving this input to the model. That is, we need to provide the batch dimension. See, this is the input shape right now, the tensor input tensor shape. But what we want is, we want this kind of input to inputs, then only we can provide this input to the our model. Okay, so what we are doing is, this is, we are adding the batch dimension. Why we are adding the batch dimension? Because model works on batches of images, so that's why we need to add a batch dimension. And this unsqueeze is unsqueeze simply means when we want to add a dimension of size 1, and this dim equals to 0 means at position 0 we want to add the dimension 1. Then we have channel, height and width of the image. Now here our input tensor is ready. Now this we will provide, this particular tensor will become the input to the model. Okay, so guys, one thing to note over here, today we are working on object detection model. Okay, whether you're working on object detection model or a image classification model, till here the steps are same. You always need to convert the input image into a tensor, right? Then normalize the values between 0 to 1. After that, add the batch dimension. These steps will be same for whether we are working for image classification problem or object detection problem. Okay, so now here object detection model. Now what it is? Let's scroll up. Object detection model. Here you can see in object detection model we have initialized our model. So we are calling this model over here and we are providing the input tensor, this tensor. Okay, and then we are displaying the prediction. So this is our output. Now let's understand the output. See, we have boxes. Under boxes we have how many boxes? This is the bounding box coordinates of first box, this is the second box coordinates, third box and the fourth box. Okay, so what it means is that our model have detected four objects in the image. On which image? In this image our model has detected 4 bounding boxes, and these are the class labels of those boxes. These are the IDs, means 18 is the ID of some class, and 52, 23 and 52. These are the classes detected by our model, and these are the confidence score. Like, means that for class whose ID is 18, for that our model is 99% sure that the object belongs to this class, 50% sure that object belongs to this class, 16% sure that object belongs to this class, and this much 6% sure that object belongs to this class for these 4 bounding boxes. Okay, now over here we were not able to see the results properly, so now let's visualize the results. So for visualizing, so guys, in this list I've just mentioned all the 80 classes which are present in COCO dataset, so that we can map these IDs to their class names. Okay, over here I'm importing the matplotlib and the submodule of matplotlib just to plot the bounding boxes and the image. And guys, now remember, Pytorch accepts the data in a different format. First it accepts the channel, then height and width of the image. But when you want to display the image on the screen, so you have to change the order. You need height, width and then channel. So that step we are doing over here. Okay, and then we will show the image, and here you can see these are the prediction boxes, labels and scores. Okay, and then here x1, y1, x2, y2, these are the 4 variables which will have the bounding box coordinates. Okay, label name, rectangle. Using this patches.rectangle we are drawing the rectangles around the object, and plt.text will provide the text to those boxes. Okay, now let's see the output. You can see the output now. Dog, we have the bounding box, then the class name, then 1.00 means 100% sure that this is a dog. Then our model is this much sure that this is a beer and this is a broccoli. Now guys, let's refine the results. Now let's write some condition, like if the confidence score is greater than 80%, then only show the bounding box, otherwise don't show it. So for that, what I have done is, see, this is the same code of visualization which we have discussed here. The only thing which I have added is this. here you can see. So I have used another variable with the name of confidence threshold, and I have mentioned 0.8 means 80% threshold. And over here inside this loop, what I'm saying is, if the score is greater than 80%, then only display the bounding boxes and then the class labels and this confidence threshold. So you can see here we have a proper result, dog, and this is the confidence score. Okay, so this kind of output you will get with the object detection model. Object detection model will find out, locate the object in the image or a video. It will draw the bounding boxes around it. It will provide a class label, and with that class label it will provide you the confidence score, and that confidence score simply tells you that how much your model is confident that this particular object belongs to this particular class. Okay, so this code I have shown you that the GitHub link is mentioned. You can get this code from there and you can try it. So I hope this video is helpful. Thank you for watching.